lesson number 5, we have the coplanar non-concurrent force system. So the forces which do not meet at one point but their lines of action lie on the same plane are known as coplanar non-concurrent forces. The resultant of the distributed loads is equal to the area of the load diagram. It is acting at the centroid of the area as indicated. The figure below shows the three common distributed loads, namely rectangular load, triangular load, or trapezoidal load. So here's the figure. As you can see, this is the centroid of rectangular load, which is equals to 1/2 plus its given base. Then the centroid of triangle is 1/3 is always in the higher part and 2/3 is always at the lower part. Then the trapezoidal load, we have 2 divided into 2, so it will become the triangle. So this is 1/3, 2/3, and the rectangle is 1/2. So the Varignon's theorem or theorem states that the moment of any force is equal to the algebraic sum of the moments of the component of the force. So we have here a given problem that says, for the given non-concurrent force system, solve the reaction of A and B. So here's our figure. As you can see, we have here a beam with roller. So here's our triangular load with a force of 5 pounds per feet, and a rectangular load with 5 pounds per feet and a point load of 15 pounds. And the distances are 3m, 2m, and 6m. So to solve our beam, we have to find the reaction A and the reaction B. So we first find the area of triangle, which is the 1/2 times base times height. And the area of rectangle is equals to base times height. So our first step is find the area of the rectangle or the triangular load. So we have to moment first at A, at point A. So the area of the triangle is 1/2 times base times height. So this is our base and this is our height. So it is 1/2 times 5 times 3 plus the centroid of triangle, which is 1/3 since it is at the higher part. So this is 1/3. So 1/3 of 3 plus the area of rectangle, which is 5 times 6. Our base times height is 5 times 6 plus the centroid of rectangle, which is 1/2 of 6. So we have 5 times 6 times 1/2 of 6 minus our RB, and moment of RB is counter to A, so it is negative, so our RB is negative times distance 6 are 3 since it is right here. So it's 3 plus 2 plus 3. So it is 8. Our RB times 8 plus the point load 15 clockwise to A, and total of distance is 11. So 15 times 11 equals to 0. So our RB is 32.813 pounds. So to find our Fy is negative 1/2 the area of triangle, negative 1/2 times base times height, which is 5 times 3 minus the area of rectangle, which is the base times height. So we have the 5 times 6 plus our RB, which is the 32.813 pounds minus point load 15 pounds plus RA. So it is all negative since all the line of action or the arrow are pointing downwards. And our RB is positive since it is pointing upwards. So our RA is equals to 19 or 19.687 pounds.